We will now determine a vector v which is orthogonal to the plane containing these 3 points, that is the points p, q and r, and we will write down this vector in component form. So here I have drawn a sample diagram of a plane with these 3 points, that is p, q and r. And the first thing that I did is I connected the points like this, that is q with p and then q with r, so that we will get two vectors, and both vectors are terminating at the point q. And then we know that a normal vector which lies perpendicular to this plane, we can get that normal vector when we find the cross product of these two vectors. That is, we find pq vector and qr vector. If we find the cross product of these vectors according to the vector products, cross products, we will get a normal vector, and this normal vector is perpendicular to this plane. So therefore, if we just find a normal vector, and thus that is our required vector v vector. So let's do this. So in the first step, we have to determine the PQ vector as well as the QR vector. So let me determine the PQ vector using the points. So we have this point, let me write down the points on the top, that is 6, -6 and -2 is the point P, and the point Q is 1, -5 and 3. So when we have to find the PQ vector starting from the point P and terminating at Q, we have to do the subtractions like this. That is, we do 1, we take the first component and subtract 6 from that, that is the second component. Basically, we have to take the component from the terminating vector, that is the terminal point of that vector. So we do like this, that is, we take the point 1 from Q and do the subtraction with the corresponding point from P, that is 1 minus 6. And then you take the next point, that is the next component, that is -5, and then you do the subtraction with the corresponding point from P, that is we have a -6, so it will be -6. And then we take the last point, that is 3, subtract minus of -2, so this will be the PQ vector. So let's simplify this. 1 minus 6 is -5, and this is -5 plus 6 is +1, and then this is 3 minus of -2 is +2, so 3 plus 2 is 5. So this is how we find the PQ vector. So I can mark this PQ vector here in component form as -5, 1, 5. In the same way, we will now find the QR vector. So I write down QR vector. I take the points Q, I write down at the top, that is 1, -5 and 3. And then the R vector, the points for R is -4, 5 and -6. So we do the subtraction like this. We take the -4 and subtract 1 from that. So therefore it's going to be, can write down in component form, -4 -1. And then I take the next point, that is 5, subtract -5. So it becomes 5 minus of -5. And finally I take the last point, that is -6 minus 3. So we can simplify this. This results in -4 minus 1 is -5, and 5 plus 5 is +10. And then -6 minus 3 is -9. So basically we get the QR vector as written in component form as -5, 10 and -9. Let's now determine the n vector, basically, which is nothing but the v vector, because both n vector and the normal vector is orthogonal to the plane. So to find this, we know from the principles or the rules of a plane, we have to take any cross product of any two vectors lying on the plane. So here we take PQ vector cross product with QR vector. This will result in a vector which is orthogonal to to the plane. So let's do the cross product. So therefore I can write down this as v vector is equal to, I have to use the determinant to find the cross product. So I put the components ijk, and then put the component of the pq vector, that is just below that, -5, 1 and 5, and then I put the component of qr vector, that is -5, 10 and -9. So we have to find the determinant of this one. Let's evaluate the limit. I'm going to expand along the first row. So I write down here as v vector is equal to I vector times, I have to hide this column as well as this row. So when I do that, I get this determinant 2 by 2 matrix. So this is equal to -9. We have to use the cross product, -9 times of 1 and then minus 5 times of 10. So it is equal to 5 times of 10 is 50. Now I put negative, and then I put the second component j and multiply this with by leaving the rows and the corresponding column. So I have to leave this row as well as this column. So when I do that, I get this -5 and 5 minus 9. So here I have to find the cross product. So that is -5 times of -9. This is positive 45 minus -5 times of positive 5. This is equal to negative 25 plus k component. I should leave the corresponding row and the corresponding column. So here I'm going to leave this row, the first row, and the column, the last column. When I do that, I get this, I have to evaluate this 2 by 2 determinant. So here I use the cross product. So -5 times of 10 is -50 minus -5 times of 1 is -5. So I put this -5. Now let's simplify this. Therefore, v vector is equal to I times of -9, -50 is -59, and then we have this -j multiplied by 45. This is plus 25, which is 70. And then for k component, we get -50. This is positive 5, so it results in -45. So we can write down this in component form as or first let me write down in the ijk form, that is -59i, this is -70j, -45k, and this could be written in component form as without the ijk, that is -59, -70 and -45. So this is the vector which is orthogonal to the given plane with the 3 points on it.